In order to find the force in each chord for the 60 kg bucket to be in equilibrium, we can start by first drawing the free body diagram of the bucket itself by placing the origin at point F. Here we have two forces. One is the weight of the bucket that is acting vertically downward. The other is the tension in the rope going away from point F. We can apply our equilibrium equation along the vertical direction to solve for the force in the rope, that in this case will be equals to the weight of the bucket as 589 Newton. Next, we can consider point A and apply the free body diagram of point A by placing the origin at that particular point. In this case, I have three ropes that is connected to point A. All are taken in tension going away from point A. The value of FAF is already known, whereas the value of FAC needs to be divided into its horizontal and vertical component. We can do that by utilizing the dimension given to us, as the horizontal distance from point A to C is 3 meter and the vertical distance from point A to C is 4 meter. Utilizing the right angle triangle and the Pythagorean theorem, we can identify the length of this rope as 5 meter. Next, let's apply the equilibrium condition. So doing summation of forces along the y-axis equals to 0, we will have a component of force FAC along the vertical direction that will be obtained by multiplying it with 4 over 5. Subtracting it with the weight of the bucket will give us the value of force FAC. Next, we can do the summation of forces along the horizontal direction equals to 0. Here also we have a horizontal component of the force FAC, which we can obtain by multiplying the force with 3 over 5. That is in the negative direction based on our reference point we have selected, whereas FAB will be in the positive direction. Simplifying, we get the value of FAB equals to 441 Newton. Finally, we can go ahead and draw the free body diagram of point C by placing the origin at that particular point. Again, there are three cars that are going away from point C, all in tension. We have already figured out the value of FAC, so the other two can be calculated by applying our equilibrium condition along the x direction and the equilibrium condition along the y direction, which give us our value of FCD as 441 Newton, whereas the value of FCE is coming as 589 Newton.